Hello friends, welcome to video lecture on kinematics of machinery. In the today's lecture, we'll learn about inversion of single slider crank chain. So let us start. Here the single slider crank chain is the modification of 4-bar chain. It consists of one sliding pair and 3 turning pairs. It is usually found in reciprocating steam engine mechanism. This type of the mechanism converts rotary motion into reciprocating motion and vice versa. In a single slider crank chain, as shown in this figure, link number 1 and link number 2. Here the link number 1 with us and link number 2 is here. So this one actually ray diagram for this one again. This one single slider crank chain is drawn here. Okay, so this indicate entire this portion. Okay, so can easily identify the different links. Okay, so here the link number 1 and link number 2, link number 1 is here and link number 2 is here, that will forms a first turning pair. Link number 2 and link number 3 forms a second turning pair. Link number 3 with the link number 4, that will form a next turning pair, and link number 4, okay, with the link number 1, that will form a sliding pair. Okay, now let us we see the case of first inversion of single slider crank chain. Now what's about this one? The same we have discussed in the earlier case. Okay, so link number 1 is fixed. Okay, link number 2 made here as crank link. Link number 3 is nothing but the connecting rod. Link number 4 is nothing but here slider. Okay, this will form first turning pair, this will form second turning pair, this 3 and 4 form a next turning pair, and 4 with the 1, that will form a sliding pair. Okay, so if you look towards this one and this one, the same diagram in front of you. Okay, but what's about the actual difference? The actual difference is here, that whenever the link number 2 becomes a driver, okay, this is the case of a reciprocating compressor, and whenever the link number this one 4 becomes a driver, this is the case of reciprocating engine. This is the basic difference between the compressor and engine. So let us start with the second inversion of single slider crank chain. So in this case, whenever the link number 2 is fixed, okay, this becomes a second inversion of single slider crank chain. Okay, now see this one. In this case, when link number 2 of the this mechanism is fixed, the second inversion of single slider crank chain is obtained. Okay, so link number 3 along with the slider at its end becomes a crank. Hence the link number 3 along with the slider 4 rotates about this B point. By doing so, the link number 1, this one, link number 1 is here, okay, rotates about A along with the slider 4, which reciprocates on the link number 1. This inversion is used in Whitworth's quick return motion mechanism as well as in rotary engine. Okay, so let us discuss about this Whitworth quick return motion mechanism. Okay, so if you look to us here, so just focus on this small portion. Okay, this one, this is nothing but the same actually mechanism is here. Okay, just focus here, A, B and C, this part and this part is identical one. Okay, so this mechanism is used in workshop to cut the metal. The forward stroke cuts the metal. Here the forward stroke cuts the metal and return stroke is ideal. The forward stroke takes a little longer time, whereas the return stroke takes a shorter time. So from this figure, if you look to us here, the link number 2 is fixed. Okay, link number 3 made as crank here. So at the end of link number 3, this one, a slider is attached. Okay, so whenever just see here, C point, if I consider that C point at C1 and D point automatically initially at point D1, so something input motion is given for this crank link number 3, then this will start the move, this one, this point D1, start moves from its initial position and takes a new position, that is at point D. Okay, so what's about this one? At the same time, this will start moves in anti-clockwise direction. Okay, so this will start anti-clockwise direction means you look towards another points. Okay, the C1 start moves from this one C1 to C. So what's about this mechanism? First of all, I'll give explanation regarding the same. So basic mechanism is here, single slider crank chain. Okay, so what's about this one? This link number 1 is extended up to this one point D. At the end of this point D, another link is connected. So link number 5 name is given for this one, and at the end of link number 5 the tool is attached. Okay, so link name given for that as link number 6. Okay, so as per our previous discussion, whenever this one the motion of this link number 3 start from this one, initially this one at C1. Okay, at the same time, if you look towards this point, initially this point is at point D1. Okay, so the displacement of this one start from C1 to C, and from D1 this point start moving from D1 to D. At the same time, if you look towards this one, the tendency of link number 5 to push this link number 6 into forward direction. Okay, means this will start moves in forward direction. Okay, so whenever actually this point moves in extreme upper side, this will move, okay, towards the end. Okay, this is nothing but the return, sorry, forward stroke or cutting stroke. And whenever this one actually moves from this point, okay, again the return stroke will start. Now if you just look towards this one, whatever the displacement or whatever the moment of this link 3 takes place about this one B point. Okay, so here the link AB is nothing but the fixed link. Already we have discussed about this one. Link number 2 is here, link number 3 is here, link number 1 is here. Okay, so the displacement of this slider takes place on the link number 1. Here the reciprocating as well as turning moment for this one. Okay, so this is about the Whiteworth quick return motion mechanism. Okay, it will take some longer time for its displacement, so automatically the time required for the cutting stroke is larger than the time required for the return stroke. So we can just say that a relation with the help of some mathematical formula, that is the time of the cutting stroke to the time of the return stroke. Okay, if you just see here, alpha divided by beta in a small way. Okay, here alpha we can just say as it is. If you just see the total angle here, what's about the total angle? 360 with us, means what's about the beta? Beta is nothing but 360 minus alpha. So you can get the total relation time of the cutting stroke to the time of return stroke equals to alpha divided by beta equals to alpha divided by 360 minus alpha. Okay, this is about Whiteworth quick return motion mechanism. So let us we'll see the next case. Okay, this is nothing but again the second inversion of single slider crank chain. So in this case, if you just see here, what's about this one? Link number 2 is fixed. Okay, so apart from this one, this will act as a connecting rod. Okay, the link number 1 will act as a here the cylinder or a fixed one. Okay, so what's about here? The link number 4 will act as a piston. Okay, so if you just see one by one here, this figure shows a rotary engine mechanism. In this mechanism, link number 2 already we have discussed about this one. Link number 2 is fixed. Link number 4 is made as one piston. Okay, then link number 1 is made as cylinder. Here instead of one cylinder, 7, in this case if you just see, they use a clear idea about this one. Instead of using the one cylinder, 7 or 9 cylinders are symmetrically placed on a regular intervals of the same plane. All the cylinders rotate about the same fixed center. Just see here the fixed center with us A. The fixed link 2 is common to all the cylinders. The only difference between the first inversion and this example of the second inversion is that the crank rotates to crank rotates and the body is fixed. You just see here, body is fixed, okay, and the crank rotates and the body is fixed in the first inversion, whereas here the crank is fixed. Here the crank is fixed and the body rotates. Okay, this is the basic difference. So what's about the next one? Just discuss about the next third inversion. So what's about the third inversion? Third inversion we'll just discuss with the help of one example, that is the crank and slotted lever quick return motion mechanism. Okay, so in this case link number 3 is fixed, link number 3 is here. Okay, so apart from this one, link number 2 is here, and this indicates the link number 1 at the end of this link number 1. Okay, another link is connected here. Let us see one by one links so that you can get the clear idea about the same. We just see quickly the crank and slotted lever mechanism, in which the link number 1 is a slider which slides here. The link number 1 is a slider which slides in a slotted lever, which is link number 4. So here is the link number 4 is here. Okay, so link number 2 is here, link number 3 is here. Okay, so this indicates the slotted lever, this one, and this will indicate the link number 1. Okay, so how it will work? So whenever the input motion given for this link number 2, okay, this will start moves about this one. So what's about the use of this one? Again, this is used for cutting the metal in workshop. Okay, so if you look towards this link number 2, initial position of this one, if I consider, you just, this actually picture gives you clear cut idea about that stroke. Okay, so initial position of all these things we'll just see here. Here is the initial position. Okay, let us consider the initial position is here. So whenever the input motion is given for this one, the displacement of this A1 point takes place from A1 to A2 to start moves. Okay, in this way, in a circular way. Okay, whatever the time required or time taken by the this one link number, this one 2, for its motion is more than whatever the time required by the same link. Okay, here is the lesser one. Okay, so whenever the displacement of the point A start from this one A1 to A2 at the same time, if you just say the link number 5 is connected with this link number 4. Okay, so this will push this tool in forward direction. The displacement of this E1 takes place from E1 to E2. Okay, this is nothing but the cutting stroke. And return stroke, you just say whenever the journey start from this point to this one. Okay, again the tool start moves from this E1 to E2. This is the case of return stroke. So as per as our discussion read with that, what were the quick return motion mechanism. Okay, so whatever the time required for the cutting stroke and whatever the time required for the return stroke. Okay, for that the mathematical relation with us, cutting time of the cutting stroke divided by time of the return stroke, here alpha divided by beta. So you can get the same formula. Okay, it will more clear to you with the help of this picture. Okay, move towards the next inversion of mechanism. So this is nothing but the fourth inversion of single slider crank chain, when link number this is nothing but again inversion, third inversion of the uh, single slider crank chain. Okay, this is nothing but the oscillating cylinder engine. Okay, so this will give you clear idea about this inversion. Okay, so in this case link number 3 will act as a connecting rod. This is nothing but the fix here. The link number 2 is here. Okay, so whenever the input motion given for this crank, okay, this crank will start moves about this point. So this indicate the link number 1. At the same time, the this one cylinder is nothing but the link number 4. Okay, so here the rotary motion is converted into oscillating motion of this cylinder. Okay, so that's why the name given for this one as oscillating cylinder engine. So let us start the next inversion of single slider crank chain. Okay, so in this case, direct example is given, pendulum pump. Okay, so another name given for this one as hand pump. Okay, so in this case, link number 2 is here, link number 3 is here. Okay, link number 4. Okay, that is nothing but the fixed one. Okay, that's why the name here, instead of first, just consider this one as a fourth inversion of slider crank chain. Okay, let us see this one example of hand pump. Okay, so in this case, you just see here the cylinder and this one link number 4 is nothing but the cylinder. Okay, what's about this one? This will act as crank. Okay, so what's about next one? Connecting rod is here, but at the same time the cylinder from this end, and this will act as a piston rod. The same case in front of you here, this will act as a piston rod. Okay, at the end of this one the piston is connected. If you just give the something input motion on this crank portion, automatically the water will start come out from the ground surface, and we can get the output here. Okay, so I hope that in the today's lecture, whatever the inversions related with the single slider crank chain discussed clear to you. Thank you.